using this same approach. Okay, I'm going to go back to my calculator. Hopefully you're seeing how the formula works, but we're just going to use your calculator moving forward. So I'm going to go to Menu, Probability, and then we're going to go to Distributions, and then maybe you'll end up memorizing what letter this is, because we have to go down. D, well, D, there we go. So now we're saying what's it for 2, okay? So the number of trials, we're having 5 questions. This is 0.25 for a success, and we want 2 to be correct, or to be successes. Push enter, and that's 0.2636. Okay, so going back to here, 0.2636. The first question is, what is the probability that a student guesses and gets fewer than 3? That would be he got 2, 1, or 0. So then how do we figure this out? We're just going to go and add those up. Now I could add those up individually, or this is where I could use what's called binomial CDF. Remember, a binomial PDF is for a particular value. CDF is for a cluster of values. In this case, it would be from 0 to 2. Now that's where you got to be careful, because sometimes people see this, fewer than 3, and they're going to put 3 in there. And that's not correct. What you're going to need to do is you're going to do binomial CDF. And when you do, you're going to need to make sure that you're looking at your number line and you're saying, okay, are we including 3 or no? If we're fewer than 3, that means we're including our minimum values from 0, and our maximum value is 2. We only want to go to 0, 1, and 2. Now watch, I could add those up. I'm going to show you how to do this on your calculator and get the same thing. We're going to do this. Go to almost the same spot. We're going to go to Menu. Probability is 5. Distributions is 5. And then all the way down, D was PDF, so I'm guessing E is going to be CDF. And there it is. So Menu 5, 5E. Now notice here, it's going to ask for similar things, number of trials. We're doing 5 questions. Probability of success is 0.25. And the lower bound in this case is going to be 0. Upper bound is 2. Because we're saying fewer than 3, so it could be 0, 1, or 2. So I did min and max, but min is lower bound, max is upper bound. Same concept. And notice you get 0.896, or like 90%. Guess what you would get if you added those 3 up? You get the same thing. So binomial PDF is for a particular value. Binomial CDF is for a cluster of values. So I'm going to write 0.896. That's my answer here. So this was 0.896. So basically, you've got a 90% chance that you're going to get less than 3 right if you have 5 questions and you're just guessing. What that means is that if you were to repeat this 100 times, if you were to take 100 quizzes with 5 questions, you'd, on about 9 of them, this is going to be how many questions you get right. You would expect about 9, oh brother, sorry, I'm writing that down. In 100 repetitions of this experiment, fewer than 3 questions would be correct 90% of the time. Does that make sense? So we were saying, what's the probability that you get fewer than 3 correct? Well, if we did 100 times, then you get fewer than 3 on 90 of those, about 90, give or take. Okay, now let's just keep practicing here and going forward. I'm going to go a little bit faster because this is taking a little longer than I was hoping for. I apologize, but hopefully you're understanding. What's the probability that a student guesses in all 5 questions and gets at least 4? So what I want you to get kind of in the habit of doing is, let's draw a number line here, okay? So here's 0, 1, 2, 3, 4, 5. Here's all of our questions. They're getting at least 4. Does that include 4? Yeah, at least is going to be an equals, so it could be 4. And then which way are we going, higher or lower? And is 5 at least 4? Yes. So basically this is saying, what's the probability that you're going to get 4 right or 5 right? Well, to do that, we're going to do a binomial CDF. Our cluster here is just from 4 to 5. So I'm going to do a binomial CDF on my calculator. It's going to be very similar to what we just put in. I'm actually just going to go up and copy this here. Oops, I didn't mean to do that part. Copy that down. But now instead of going from 0 to 2, we're going to go from 4 to 5. And notice that's going to happen 0.015 or 0.0156. So basically like 1.5% of the times. Not very good, right? So I'm going to write that here, 0.0157, I think, with rounding. What that means is that if we were to do this 100 times, we would get 4 or at least 4 questions. So 4 or 5 questions would be expected to be correct about twice. 2 times. Not very good odds, right? So guessing not very good. Okay, so then what is the expected number of questions we expect to be correct? Well, that's going back to the formulas we used. We just used NP. We're asking 5 questions, and the probability we get it right is 1/4. So this is 5/4, or in other words, 1.25. So we would expect that you'd get, like, the mean number of questions you would get right is 1.25. And that seems about right. If we look at our chart, 1 is the mode, it's the highest, and then it just kind of goes down from there. And so if you're going to guess on 5 questions, on the long term, you're going to get about 1.25 correct. In order to get to sigma, the standard deviation, we do square root of NP and 1 minus P. So we did 5 questions. The probability of success is 0.25. Probability of failure is 0.75. When I go and I put that in my calculator, I get 0.97. So standard deviation is your average distance from the mean. So we expect you to get about 1.25 correct, but that fluctuates on average by about 0.97. Last question for this example says, what is the range of usual values? Well, what we answered at the top of the page was that as long as NP, as long as we take that formula from up top, let me just scroll back up so you can see it. As long as this is the case, then we can expect the distribution to be approximately normal, which means it follows the 68, 95, 99.7, which means our usual values would be within 2 standard deviations of the mean. So what we're going to do first is check, is NP 1 minus P greater than or equal to 10? Well, we're doing 5, and then P is 0.25, and 1 minus P is 0.75. Is that greater than or equal to 10? I think I've got some bad news because I am fairly confident that is not going to be greater than or equal to 10. So for this case, we actually don't know if this is going to be a normal distribution because that's not a true statement. So we can assume it's normal, but usually what you would do at this point is you would go up 2 standard deviations, down 2 standard deviations. That would cover 95% of the data. So if we were just like assuming that this was normal, I would take my mean and subtract 2 standard deviations. I would take the mean and add 2 standard deviations. And when I do that, the mean was 1.25 and the standard deviation was 0.97. That takes me down to negative 0.69. Sorry if you can't see that. And then if we do 1.25 plus 2 times 0.97, that takes us up to 3.19. In other words, the usual values in this case is going to be from negative 0.69 to 3.19. You're like, well, you can't get negative. Well, exactly. This isn't a normal distribution. It's a skewed to the right distribution. Therefore, we really shouldn't be assuming it follows 68, 95, 99.7. But you are going to see ones where your sample size is larger, so we can say that that's true. All right, now we've gone over how to do this. We can go a lot faster now because we know we're not going to be using like the formula or using tree diagrams. We're just going to kind of move on forward using just our calculator. So let's do this a little faster here. We just got 2 more examples we're going to go over. Stay with me. If you need to pause it, go for it, right? Okay, according to an airline, flights on a certain route are on time 75% of the time. Suppose 10 flights are randomly selected and the number of on-time flights are recorded. So, is this a binomial experiment? First off, is there a fixed number of trials? It says there's 10. Yep, we're only going to look at 10. Are these flights independent of each other? Yes, because they were randomly selected. When we randomly select things, it eliminates bias so that they don't influence each other, therefore they're independent. Is there a clear success and failure? Yeah, either they're on time or they're late. So, they're on time, success. They're late, they're a failure. And then lastly, is there a probability of success that stays the same? And yeah, it says they're on time 75% of the time. Okay, so find and interpret the probability that exactly 6 flights are on time. Is this a PDF or a CDF? Remember, PDF is for a particular value of X, CDF is for a cluster. In this case, it says exactly 6. That tells me we're going to do PDF. So the probability that X, which is our number of on-time flights, is 6, we're going to do a binomial PDF. And I like to write out what I'm putting in my calculator so the person correcting it knows that I know what I'm doing. That way I can get partial credit if maybe I mistyped something. So then I'm going to go in my calculator, and we're going to put in our info here. We're going to do a binomial PDF, okay? Remember, to do that, we go to Menu, and we're going to go to 5, 5, and I think it was D, 5D, binomial PDF. Great. We're doing 10 flights. Probability of success is 0.75, and we're going to be looking at what's the probability that exactly 6 are on time. When we do that, we get 0.146. So about a 15% chance that exactly 6 flights would be on time. So I'm going to just fill in what I put there. So we put in that the N is 10, probability of success is 0.75, and we looked when X is 6, and we got 0.146. There we go. Let's go to the next question. Oh, you couldn't see what I was just writing. I'm sorry. Let me go back to this. So I just filled in the answers. Cool. Find and interpret the probability that fewer than 6 flights. Is that a PDF or a CDF? Fewer than 6. So I'm going to go and draw my number line. Here is 6. When we say fewer than 6, are we including it? No, it would be less than 6. So I'm going to do an open circle and go that way. So this is a probability that X is less than 6. When we do that, it means our minimum number of on-time flights would be 0. You can't have negative on-time flights. And I'm going to use what they say. This is our lower bound. Our upper bound is going to be, is it 6? No, it's going to be 5 because we don't want it to be 6. We want it fewer than 6. And then our number of flights is still 10, and the probability of success is still 0.75. So let's go into our calculator and calculate all that fun stuff. Remember, this was, hopefully you're getting faster at this now, Menu, 5, 5, and this one's E to get to CDF. We're doing 10 trials. Probability of success is 0.75. Our lower bound is 0, and our upper bound is, remember, it was fewer than 6, so it's 5, so be careful with that. And I get 0.078. So there's roughly an 8% chance that fewer than 6 flights are on time. So that's pretty good news. The majority of them should be on time. That's a relatively low percent. All right, so now find and interpret the probability that at least 6 flights are on time. So again, I like to look at my number line. At least 6. Does that include 6? Yes, so I'm going to draw a solid circle. Say I am including 6 because 6 is included in at least 6. Then which way are we going? At least means we're going to be looking at greater than or equal to, because 7 is at least 6, 8 is at least 6, but 5 is not at least 6. So we're doing the probability that x is greater than or equal to 6. And this is going to be a binomial CDF because it's a cluster of values. Our lower bound is going to be 6, and our upper bound is going to be 10. Everything else is the same. We got 10. Probability of success is 0.75. Okay, so now go into your calculator. We're going to do menu 55D, or sorry, E for a CDF. 10, 0.75. Lower bound, we said, is going to be at least 6, so that could be lower bound is 6, upper bound 10, gives us 0.92. So, yeah, there's a 92% chance that these flights are going to be, that somewhere between 6 to 10 flights are going to be on time. That's cool. Okay, find and interpret the probability that between 4 to 6 flights inclusive are on time. What does the word inclusive mean? It means we're including 4 and 6. So this is a probability that we're between 4 and 6. So this means we're doing a binomial CDF again. Our lower bound is going to be 4 because we're including that 4. Our upper bound is going to be 6. And then we still have n is 10, and the probability of success is 0.75. So I'm going to go back. I'm just going to copy the one we did before. And we're going to make it instead, though, that it's 4 to 6. Remember the comma's down in the bottom left. And I get 0.221. So there's like a 22% chance that between 4 to 6. So 4 flights, 5 flights, or 6 flights. Would it be unusual for all 10 flights to be on time? So if we're looking at the probability that all 10 is at PDF or CDF, there's just one value, so it's 10.
Same drill as yesterday.
Same as yesterday, yep.
All
Thanks.
right, man. Have a good one.
You too. All right, so that means we're going to use PDF because it's just one value here, okay? So I'm going to say probability that x is 10, and I'm going to go in my calculator and do a binomial PDF. So I'm going to go to menu, was it 55D, is that what we said? Yes, binomial PDF. We're doing 10, and we get 0.75 for probability, and we want all 10 to be on time. There is a 0.056% chance of that happening. Is that unusual? Well, what makes something unusual? It's less than 5%. Is 0.056 less than 5%? No, it's greater than. So it's not unusual because it's more than 5%, just barely, but it's still more than 5%. All right, you see how we're going faster now that we've got the calculator? I hope you're like, okay, I'm getting the hang of this. PDF for a particular point, CDF for a cluster collection, right? Some kind of word there. Whew. Last one. Hang in there, you guys are doing awesome. According to a study done, the probability a randomly selected individual will not cover his or her mouth when sneezing is 0.267. Oh man, in today's society, you better be covering or people are going to get angry, right? Suppose you sit on a bench in a mall and observe people's habits as they sneeze. So is this a binomial setting? Well, let's look at A. What is the probability that among 10 randomly observed individuals, exactly 4 do not cover? Is there a fixed number? Yeah, it's 10. Is it independent? Yeah, we're doing random. Do we have a success or failure? Do they cover or not? And then, is there a probability of success? Yeah, it's point. In this case, our success, it's kind of funny to think about it this way, is that they don't cover, right? This whole thing is, what's the probability that they do not cover? Now, we would consider not covering a failure, but you have to kind of think of what we're asking here and make sure we're on the same page. What is a probability that among 10 randomly observed individuals, exactly 4 do not cover? Is that a PDF or a CDF? That's going to be exactly 4 PDF. So the probability that x equals 4, we're going to call that a binomial PDF. to say we're looking at 10 trials. The probability of a success, which is a probability they don't cover, is 0.267. And what we're looking at is what's the probability that exactly 4 do not cover. Let's go ahead and plug that into our calculator. I'm just going to come up to this one we did just barely and copy that down. So we're still talking to 10 people. Our probability of success, I have to check that, was that 0.267? Yeah. 0.267. And we said what's the probability that exactly 4 do not cover. I'm going to put that in and get 0.166. So about a 17% chance that exactly 4 will not cover their mouths. And those 4 people are about to get slapped. Okay, so there's 0.167. What's the probability that among 10 randomly observed individuals, fewer than 3 do not cover their mouths? Okay, so what does fewer than 3 mean? Is 3 included in fewer than 3? No, so we're not containing 3, and we're going less, and fewer would be less than. So this would be like 0, 1, and 2. So is this a binomial PDF or CDF? It would be a collection or a cluster, so this is a CDF. So I want to do binomial CDF. We're basically saying, what's the probability that x is fewer than 3, less than 3? When I do that, the lower bound is going to be 0. The upper bound is going to be not 3. Remember, don't choose that. We're only going to 2 on this one. And then we're going to have the same number of trials as 10, and the probability of success is still 0.267. So if I go back now to my calculator, we're going to do a binomial CDF. That's menu 55E. Binomial CDF. 10 people, we've got a 0.267, and we're going from 0 to 2. I put that in, 0.475. So there's a probability that it's about almost 50% that it's going to be fewer than 3. So that's good, because we don't want to be slapping too many people. So I'll write that down. And then last but not least, would you be surprised if after observing 10 individuals, fewer than half covered their mouths when sneezing? So let's think of that again. We're going to watch 10 people, and we're wondering if fewer than half covered their mouth. Now on the other ones, we've been saying they do not cover their mouths. So in that sense, which way are we going? You have to kind of keep the context here. So here's 5. And this would mean, so if 5 people covered their mouths, it means 5 people did not, if we're asking 10, right? So if we're saying fewer than 5 covered their mouths, that means more than 5 did not cover. So more than 5 did not cover, that means we're looking at 6, 7, 8, 9, 10 on this one. Does that make sense? Because the way we have set this up is that a success is that they do not cover. And now this has kind of flipped it on us and said we're looking at fewer than half covered. That means if fewer than half covered, that would mean 4 covered, 3 covered, 2 covered, or 1 covered. If we go back to the way we've been thinking about it, that means 6 did not cover, 7 did not cover, 8 did not cover, 9 did not cover, or 10. So that means we're going from 5, above 5 or higher, so that means it would really be from 6 up to 10. So pay attention to the wording of the question. It's a little tricky here. So again, this is a binomial CDF, and since we kind of changed the phrasing, we're actually going to say that x is, it's less than it's greater than or equal to 6, but less than or equal to 10. So we're just in that range between 6 or 10. So my lower bound is going to be 6, my upper bound is going to be 10, the trials is 10, and the probability of success is still 0.267. So let's